afternoon, everybody. It's in Istanbul. It's an honor to be with you. Myself and my colleague, Dr. Adel Fernandez here, are going to be presenting to you this afternoon about enabling smart cities using GIS. So when we look around the world with the cities and communities that Esri works with, we see some commonalities in the aspirations that cities have. All cities are striving to be sustainable, livable places where they can provide safe communities for their residents and visitors, places that are attractive for tourists to come and visit. So cities around the world are striving to make their locations places that are attractive for tourism, for business investment, and for commercial engagements and endeavors. So cities and communities around the world are, in many cases, functioning very well and providing services and solutions that the citizens and residents of these cities rely on to go about their everyday lives. But a lot of the time, we see that governments are actually not innovating quite as well as they could do. They're not providing services that might be sustainable or repeatable or indeed integratable into existing systems. And also, the cities that we see in our region especially are all very competitive in nature. This is, I guess, human nature. Communities want to provide attractive services that encourage people to come and participate in the work that is undertaken in those cities and communities that they're responsible for. They want to provide the highest quality of life for their citizens and residents. And in some cases, they need some help and guidance in doing this. So the cities that we work with, generally we see have a number of challenges and limitations, and these generally fit into three areas. Firstly, there are people and human resource challenges. Cities and governments are increasingly asked to do more and more and provide increasing number of services, but for ever decreasing budgets and shrinking amounts of financial support. So hiring new people or bringing in external support can sometimes be a challenge. Then physical infrastructure in many cases. So when we talk about physical assets like buildings or utilities or the roads and bridges that we drive along, many of these in some cases are actually nearing the end of their operational life and need significant investment to keep them together and keep them working and functioning well. And that can be a challenge. And lastly, IT and technology. There are constraints and limitations around those in the cities that we work with. Many governments have legacy systems that they're trying to integrate with new modern platforms, and they're finding that quite complex to do and requires kind of expensive custom integrations, which are obviously not sustainable in the long term. So these are the kind of challenges and limitations that we see. And when we add those to the kind of global challenges that we see that Dean spoke about this morning, challenges around biodiversity, climate change, increasing urbanization across our cities that we see around the world, health issues, demographic issues. All of this adds up to a huge amount of complex situation in our cities and communities that many governments are actually struggling to deal with. Our cities need to begin to act smarter, and really this is where the whole Smart Cities Drive and initiative stems from, is the need to behave in a more efficient, more optimized way to do more with less. So how do we go about fixing some of these limitations? Well, Esri's vision, which we heard about this morning, is really to enable communities to act in a smarter way, to employ smart technologies like GIS to provide content and context to our cities to create better understanding. We need to leverage four key things: people, process, technology, and ultimately the data that our cities have to do things in a more optimized and more efficient way. And of course, the science and the tools that we have at our hand to actually do this is geographic information systems technology. GIS and mapping are becoming fundamental tools for our cities and communities to leverage to start acting in a more optimized way, providing that fundamental understanding of our world. GIS provides the framework and the process for enabling a smarter world. And indeed, this technology, as we saw this morning, is being driven and evolved by many of the technology trends that we see today, from cloud computing, digital transformation, the Internet of Things, right through to the use of new data capture techniques from drones and satellites and so on. We see better connections and integrations between the systems that we have, bringing together advanced analysis on the data that cities hold to give them better insights into the patterns and trends that their cities are undergoing. So GIS is really this platform for rich data visualization and analysis that our cities are really now beginning to understand and leverage to do things in a more optimized way. But we've seen a lot of talk today about the GIS platform, about ArcGIS, and really for cities, they're struggling to understand, what do I need to do first? Where do I start to implement this technology in the right way? So we've identified 5 core capabilities of the ArcGIS platform that can enable cities to develop in a smarter and more optimized manner. And we're going to talk through those for you now. So as with anything, smart cities begin with planning, design and planning of the urban environment in an optimized fashion. So smart GIS is really revolutionizing the way we go about our planning and design processes, integrating and making data available to design, which maybe in the past was done in a more siloed or standalone fashion. So we now actually have this methodology that we refer to as Geo Design, which enables us to bring rich data and geographic analytics and thinking into the design process so that our architects and our engineers can design urban systems that are complementary to the existing systems, both natural and urban, that are in place. This methodology actually enables us to work through designs in an iterative manner, taking data a step at a time, working through different design scenarios, evaluating as we go until we reach an optimal decision for the city and for the community. And then, of course, the technology itself lets us engage with key stakeholders and present these visualizations and designs throughout the process. Traditionally, this has been done using two-dimensional technology, and Esri has supported this workflow, this design and planning workflow for many years. But increasingly, we're now moving into the 3D world and leveraging 3D technology through the ArcGIS platform to enable more intuitive design and planning. You know, our world is 3 dimensions, so why not use three-dimensional computer technology to enable us to plan and design more effectively? So we can start with building 3D city models, like this kind of simple block-based design here. Or indeed, we can go to the other end of the spectrum and implement these rich, detailed, textured models of a city, data captured from reality capture methods like from drones or satellites. And using these techniques, we can start to build up what we might refer to as an urban database, which can then feed into our planning and our design processes for transport, for buildings, for utilities, and every other aspect of city life. So we can start to leverage data capture techniques from LiDAR and laser scanning. We can bring parcel data from 2D and then extrude these buildings out into 3D, applying realistic textures to buildings, leveraging imagery as well throughout the process, and really building up what we would refer to as a 3D system of record. So really the authoritative record of our assets and resources for the city, but leveraged in a 3D manner. Now, one other important input to this is indeed building information modeling, or BIM data. Now, we're seeing a huge amount of interest in this around the world, and cities across Europe and the Americas and Asia are now mandating the use of BIM technology in design workflows. So we have engineers and architects using BIM tools to do more optimized design processes. But GIS still has an important role to play here in providing that context and providing that content of the world in which the design is taking place. And then indeed, once the BIM model itself has been created and design and construction is underway, that BIM data can then feed back into the GIS platform and enable us to do value-added services such as asset management or facilities management. So we can take this rich BIM data and, you know, maybe for the GIS we don't need detail down to the chairs and tables, but certainly the spaces that are built inside the buildings and the rooms and the utilization of these areas, all of this can come into the GIS model and inform us and provide us with a better model for doing these functions. Taking that a step further, we can actually then envisage these kind of 3D cadastre applications. So these let us look at space planning, office space utilization, things like floor area ratio metrics, and a variety of other KPIs can be leveraged through these brand new kind of 3D visualizations. This see-through application lets you visualize any kind of data using a 3D model without having to peel away layers of the exterior. You can actually see right into the building and see exactly what's going on. Now, when we start to look at these kind of engaging 3D applications, we're really starting to get into the area of what we would call the system of engagement. And indeed, that is the second core capability of the GIS platform that we would recommend cities start to begin with. So creating this system of engagement is really taking our systems of record that many government organizations have had and built up over years and extending that out into the other enterprises, into business, and indeed connecting different organizations and communities together so they can all benefit and leverage from this GIS technology. Our spatial literacy as a people has generally improved over the last 10 to 15 years, and there's research out there that has measured this. Applications in the consumer world like Google Maps and Apple Maps on our iPhones, these have taught people how to use directions and location-based technology more effectively, and that's now being brought into the workplace. And we're seeing these kind of new apps that are location-driven being made available for citizens across our cities and communities. And of course, the best place for any city to start when leveraging GIS-based apps is the out-of-the-box range of applications that we have that work with the ArcGIS platform. We heard this morning about these, but we have field applications, a full suite of apps to enable and optimize better field workflows, apps for the office that integrate with Microsoft's tools and business intelligence applications, and indeed a set of applications that work with the community as well. So story maps, tools for crowdsourcing data, and so on. All of these apps work straight away out of the box with a city's governmental data as it is today. And if they want to take things to the next level, they can indeed use our range of application builders and templates, or our App Studio technology, which lets you build native mobile applications for iOS and Android and other modern platforms. Now, when we start looking at these kind of applications and sharing this information out through a system of engagement into the community, we start to actually look at what we now call the Community GIS. And this is the third core capability that I want to talk about. So as I mentioned, we have cities and governments around the world that have been using this GIS data and technology for many years. But what they're now realizing is that the value that they've invested in keeping this data up to date and keeping it maintained can now be extended beyond by opening up information, opening up data and applications into the wider community. And when we say the wider community, we're talking about citizens, we're talking about non-governmental and humanitarian organizations, civic organizations, academia, startups, and beyond. These organizations can leverage the data and applications and tools that are made available by the government to start giving back something to government and the community. I mentioned earlier about these lofty ambitions that all cities have. They all want to be sustainable, they all want to be resilient, they all want to be safe. But really, it's through the Community GIS pattern, as we see it, that really takes these aspirations and turns those into realistic initiatives that can actually be implemented for real. And these could be initiatives around things like reducing traffic congestion or reducing health epidemics across a city, reducing energy and making sustainability a key feature of a city. Many of these initiatives cut across many different departments and agencies of government. So for instance, an economic development initiative where we're looking to stimulate investment from overseas investors, perhaps. That cuts across economic development, infrastructure organizations, land management, IT, and beyond. So there's some cross-departmental, cross-governmental organization that needs to happen here. The same goes for a Vision Zero initiative, which is about reducing the number of accidents and fatalities on our roads. So transportation, EMS, public safety, all of these different organizations of government are now required to collaborate together to solve the challenges of accidents on our roads. And really, it's the Community GIS pattern that enables that to happen, both across government, but then extending out and engaging with our community as well. So bringing city leaders into the picture, sharing information with startups and developers and NGOs, and really getting feedback from these organizations in terms of how these initiatives can make a real impact on the ground. Now, we're starting to see some real interest from cities around the world in this new Community GIS implementation. And the first city that Esri has worked with is the city of Los Angeles, who have recently implemented a Geo Hub application. Now, this is a publicly available website which enables city staff and residents and visitors and tourists to LA, but indeed anyone else across the globe can access this information that's on this website. They have a range of initiatives that they launched initially. This one is around keeping the streets clean across the city. So the government went out and measured all of the city streets in terms of the cleanliness, and then they're sharing information out with the public about the kind of activities that the government is doing to improve the quality of the streets and reduce rubbish and dumping and things on their streets. You know, this is aiming to make the quality of life for those LA residents much better. Another initiative is around bringing information together for street and public works. So instead of being surprised when you have a construction crew in your road that's digging up the street to replace a utility line or some other kind of public service, this application brings together all those disparate pieces of information and puts them in one configured web application, enabling residents and tourists alike to actually find out what's going on in the neighborhood. And of course, that helps reduce the number of times the road has to be dug up as well, providing better coordination through this Community GIS system. So this has been an initiative that's been spearheaded by the Los Angeles Mayor's Office and has really made some great strides in bringing data together from different organizations across the government and actually sharing that in one common platform. There's a range of open data that's available through this application as well. So you can download data sets about initiatives like Vision Zero, or you can leverage the APIs that the city has published as well to pull that data directly into a community application and share that information with your colleagues. Now, this summer at the Esri User Conference in San Diego, we launched a new Arcgis Hub application. Now, this is a new configuration of Arcgis which connects to the enterprise GIS that a city already uses. And this provides out-of-the-box configurable tools to implement the Community GIS for around the world. And it provides social logins through Facebook and Google+ and other mediums to provide access to citizens into this application. So you can start to leverage the data. You can leverage Arcgis tools and analysis and visualization functions through this platform. So it lets you configure initiatives out of the box using this simple three-step process of firstly, how you inform the public about your initiative. Secondly, about how you listen to the public and gain feedback. And thirdly, how you monitor the progress of an initiative. How are things changing over time? Is this initiative having an impact in my community? And then city leaders are provided with dashboards and tools to monitor the uptake and access to this application and enable methods to roll this out to the community so that everybody benefits and leverages from this technology. And we don't expect you to build these initiatives from scratch. We actually provide a whole range of these that work out of the box. So we have Vision Zero, we have health-related ones, but you can, of course, build your own as well. And the early adopters to the use of this technology are actually feeding these initiatives back to Esri so that we can build them into the application for future users. So this is an exciting time in terms of using this app. It's going to be available at the end of this year, but we have an early adopters program which is open right now. So if anybody, or any city governments or local governments here in Turkey would like to start using this kind of technology to start engaging with your communities, then we'd be very happy to talk to you about how we can bring you into the early adopters program. Okay, and with that, I'm going to pass over to my colleague Adel, who's going to talk about the fourth and fifth key capabilities for smart cities.
Thank you. Thanks, Richard. Well, it's amazing stuff. These pillars are, as Richard mentioned, they are fundamental to how a city turns into a smart city, brings all these capabilities together to kind of help us do what we do best, which is basically having a city being more sustainable, livable, secure, and safe for people to live in. Now, so we touched on these first 3 pillars. So they're basically the 3D design, the urban planning. We've also touched on the system of engagement and Community Gis. What I want to talk about now is switch it, well, up or down a gear. Basically talking about the IT, the Internet of Things, and how does it benefit from real-time GIS. And also want to talk about how do we drive efficiencies and decision-making from data analytics based on geospatial information. So essentially, just to talk again about the kind of continuum of technologies that Esri today, not Esri not 5 years ago, 10 years ago, today Esri does gets into that technological continuum of technologies that are quite hot nowadays. So starting from cloud computing, which really has transformed our spectrum and how we analyze big data sets very fast, and down to the mobile technology where people use their social media, their phones for everything. People manage the workforce nowadays on your phones. That's another power that we've got today. Other things to do with the visualization, the nice 3D stuff that we just seen since this morning, actually. All the 3D bits that we have in Esri and others is just amazing. It's amazing power that we've got. And down to all the other stuff that we have to do with the sensors. So we've got lots of sensors nowadays, not just our phones, but there are sensors everywhere. There's smart sensors on the street. We have data capturing the vehicles. We have data on every person in the street. We understand exactly the dynamics of our city. So that gives us a big potential to really take this information and do something with it. So gathering all this type of information together and all these data sets, we can easily do what we can do best, which is analytics in the end, and trying to apply things to do like these clever new innovative algorithms in machine learning and others to kind of enable us really inform our decision making much better. So again, just like we mentioned before, location is at the center of everything. So location is the key. And we absolutely know that. We're here in an Esri conference. We understand that location is powerful. So what we want to do with that is answer questions that face all big cities nowadays, such as what is the common patterns of travel of people within a city, which helps us with the tourism movement. Turkey, for example, is a prime example of how tourism is thriving, and how do we manage that is by understanding how people move around the city, how the tourists come into this city and other cities around Turkey, and they kind of go to certain places to buy certain things, go and visit certain locations to experience, have a certain experience that the typical tourist would have. So how do we enhance public transport? How do we put the right bus stops in the right locations? How do we have the city be more fluid, get people from point A to B easier? How do we enhance our healthcare system? How do we understand our pandemics? How do we answer all these questions to make the city more sustainable and safe and easy to live in? So what we do here is we can leverage things like the new capabilities we've got, so the IoT capabilities, the analytical capabilities. These are the capabilities that we can harness and we can work with very easily. So just backtracking a little bit. So with Geo, the concept of Geo in the past was based in geography, essentially. And geography was, as you can see, there were maps. There were maps used for cartography, for navigation possibly, for capturing boundaries of a kingdom. You want to understand where the Ottoman Empire went, so you want to have a big map for that. That's essentially what we captured the word Geo for in the past. Nowadays, we went beyond that. We had the rise of spatial analysis, essentially, and that happened, again, like somewhere a couple of hundred years ago, or a bit more than that. And that was a classic example that I really like quoting, which is the break of cholera in London. And with the break of cholera, we didn't really understand what was the reason for that outbreak. People didn't understand, was it transmitted through air, through water, through sewage, was it people getting from contact from one person to the other? They didn't understand how it spread. And they can't control a disease if they don't understand its dynamic, how it moves. So what happened then, Dr. John Snow down there, what he did is in 1854, what he did was essentially map all the areas where he had cases happen. He literally went on a map and kind of drew lines with his hand. And that was for him to gain an understanding where most cases happened, where they happened in the streets of London. And what happened there is that he kind of counted the places, and he realized that if you overlay that layer of strokes with another layer of the other infrastructure bits of the city, so if you underlay, for example, where the water pumps were, he realized that there was one specific water pump that where all the diseases occurred around it. So this is where people used to go and drink the water, or get to the water supply. And that's when he realized that, well, then that must be the reason. And he realized that there was reason that he stopped that pandemic. And that was all due to spatial analysis. That was, just basic spatial analysis, but just by counting stuff without computers, before anything of today's technologies that we've got. So beyond that, what we've done is that we've gone way beyond that. So what we've done, we started using digital media to take us beyond that. So to do things like play with the sizes, the visualization techniques to play with the spatial aspects of a map. And then we took us beyond that by playing with more than that, color hues and all the other visual variables that we've got. But as well, create heat maps and hotspots and cold spots. But then afterwards as well, go into the age of big data, which is essentially, what if we don't have only like 200 or 300 cases. No, we've got millions and millions of cases, and it's spreading across the world. How do we instantly now understand how this data is analyzed and gain this insight straight away? And that's why we have to harness the technology that we've got nowadays with all the big data components that we've got. So that was a very nice animation to kind of prove that. Today, geo is everything. Geo is not just geography. It's not just a map where we kind of put territories and navigate. No, it's more than that. Today, with the social media, the break social media, this is a very nice piece of work that was done by the University of Illinois. But essentially, capturing the Hurricane Sandy moving around and capturing the social media from different people tweeting about it. And you can get the sentiment, whether it's positive or negative. And you can understand by that whether people were in distress, real time, saving lives, or not. And that takes us to the point of what was basically the talk that was before lunch, which is the species that adapts best, it prevails, it survives. And that's essentially, if we use these technologies to kind of adapt, to be able to kind of deal with natural disasters, that's when we can really survive, not just survive, but as well thrive and take advantage of these disasters in some cases. So that's a very interesting notion, because on that is live information, that is IoT in its briefest form. So this is where we have sensors everywhere. A phone is a sensor, a human is a sensor. And that's the notion that we like to understand. Beyond that, beyond your built environment, as we were talking before, you've got lots of sensors which are humans. You've got as well traffic sensors. You've got several sensors that, for utilities with smart metering. You've got thousands and thousands of sensors within the city. Even the natural environment, you get all the drones that we've got nowadays that capture images constantly. We've got satellite imagery. We've got several other sensors that we could bring together and build a picture real time now. And based on that, we could, again, do our real-time analysis, get our real-time data, do our analysis as we go, and using big data and using other mechanisms that we've got, and that we could face and answer questions like situational awareness, understanding exactly people trying to save lives now. How do we save them? Where do we go? Where do we look first? Where do we allocate our resources? Other things like the instant analytics, we can understand straight away what's the cause of pandemics, just like the story of Jon Snow. The other story of alerting, what if we could communicate back, the citizen engagement, what Richard was just talking about. When we connect back with people, we can send text messages to people on the phone based on their location, tell them, you better move from here because a disaster is coming. And these are all the real-time notions that we could use and literally save lives today. So just to talk a little bit on the technical side, the architectural side of ArcGIS, basically all these sensors go into the ArcGIS platform, and what happens there, a component which is called Geo Event Server. If you haven't worked with that before, it sucks in, ingests all this type of information. What it does is that it translates that information into two different bits. It saves it in the relational data store, where everything is stored very, very briefly. But what if I have got a big amount of data, lots of sensors with lots of data? That's what, when Esri has the big data store, that's where we store the data, index it in a very space and time, spatiotemporal manner in order to retrieve it very fast and run analysis even faster. And then once we're done with that, how do we run analysis? We take from that data store and we deal with Geo Analytics Server. Okay, and that's how Esri kind of views its continuum of technologies nowadays. Okay, enough with technology, enough of that. Let's talk a bit about how is this applied in real life. So down here we've got an example of basically a dashboard so that's a visionary dashboard for the city of New York. And what we're trying to see here is live trying to capture data from traffic, so data from cameras such as CCTVs and ANPR, automatic number plate recognition data, data of collisions, and what's the effect of collisions. Do we have pedestrians that were hurt? Do we have cyclists? How many cyclists were hurt in these events? Motorists and so on. And that's a live dashboard, basically, to report that back to police agencies, to hospitals, in order to better manage a situation that's at hand. And that's very slick. Another example up there is the city of Auckland in New Zealand. And basically what you've got there is you've got live traffic of all the buses in the city of Auckland. It's a live information, so every bus has a sensor on it. It reports back to our main HQ. We see all that on a map. We don't just see the buses. We also see other information such as CCTV cameras. We can plug into any of these cameras and try to understand exactly what's happening in the field. Beyond that, we can use all the aggregation and big data capabilities to kind of merge that and try to see it in an aggregated form to make it easier for me to understand where these movements are happening, where's the congestion shifting. Okay? Other examples are like, again, smart parking and finding basically spaces. Not just that, but as well, we can go beyond that. We can have, based on the data that we collect every day, we could start doing inferences, such as realizing that on a Friday evening, these car parks usually tend to be busy because they're next to certain very popular restaurants. And then we can make these predictions and say, like, if you're going to get there in an hour, so navigating there in an hour, what you could do is that you could avoid these parking areas because their chances are they're going to be busy, and go to these instead. So you could build up all these kind of models on top of these systems in order to make it more intelligent, not just real time, but as well intelligent. So another example here is having taxi companies. So today, with all, without mentioning names, you've got companies that you go on your phone, I want to go home, I want to go from point A to B, so I order a cab, a taxi, and I go, and it comes, picks me up, drops me somewhere else. So basically, these kind of companies want to monitor and understand, essentially, how is the supply, the demand, and how are they able to fulfill the gap between supply and demand. So for that, they require lots of dashboards to tell them different things. So here is an example of a certain city, and within the city, you've got different neighborhoods. As the supply and demand increases, so per polygon, you kind of calculate how many points are inside, and it kind of tells you whether a neighborhood is in short of taxi drivers or has extra taxi drivers that don't have any lifts. And then you can rearrange and redirect these taxi captains or these taxi drivers based on the neighborhood they're in. So that's a very useful piece of information because that makes the service a better service, which makes the transport system faster, which helps very much with managing your fleet. Other examples here are within the sector of utilities. So within utilities, again, you've got lots of smart meters. You've got lots of information. As a utility company, you're, let's say, a water company or an electrical company, and you've got lots of sensors everywhere, smart meters and others. You've got lots of people calling in the phone and saying, well, hey, my water is not working anymore. You want to understand exactly where these occurrences happen and what the reason is. So on the phone, you reply straight away to that person and say, hang on a minute, on my map, I can see a person that is straight next to, like at the back of your house, literally fixing your, that issue. So you can see on one map, on just one view, you can see the exact live status of what's happening. And that not only makes things faster, but that just helps the whole working procedure of what's happening within the organization. Other things such as service outages, so understanding exactly where outages happen and doing clustering on the fly, so we could understand if certain parts, we got complaints from these areas, you can realize later on that, well, that chances are, using, again, network modeling, we can understand what part of the grid is down for some reason. You could also do managing your workforce. So on the same map, you can see also where your engineers are, where the people, as we were mentioning, where your people are fixing things. And not just that, but you can also, use another interface that we've got, you could send tasks and assignments to people in order to adjust what's happening there. Another part of things is basically managing crowds. So that's to do with, again, crowd management and event management. So we have a big football stadium. We've got lots of people going into it. We want to understand the dynamics of that, the area surrounding the stadium, the vehicles going towards the stadium. We want to analyze that pattern and realize if there are any problems that evolve there. And that's when we kind of use very much the Internet of Things. We can understand from things like social media, from cameras with computer vision to try to understand how many people are in every part of the picture. And that's when you kind of can allocate your resources better, put the people, the police cars, for example, in the right places, put ambulances in the right places, put people to kind of manage the traffic better in other places, open more doors, shut more doors. There are several examples. I mean, among them are the Boston Marathon, Baltimore riots. There's an example, actually, that we're working with SAP to ingest data from SAP HANA in order to try to understand the pilgrimage, the Hajj in Saudi Arabia. And that's another example. 3 million people walking into city, within a period of a week or two. And what do you do with that big number of people? And that's when that technology helps us massively. So jumping from IoT, from all the sensors and all that kind of things reporting back to me, the live information, now talking more about the numbers. So again, there's a very good saying by Edward Tufte, which is one of the leading statisticians basically in the data visualization area. But what Edward Tufte came up with says, well, if statistics are boring, then we've got all the numbers wrong. Well, essentially, there's always a pattern. In any data that you've got a pattern. As a GIS person, you would see GIS assets, and then you realize, well, there isn't much of a pattern. But if you've got lots of data, there will definitely be a pattern. There's always a pattern. So just to talk about the continuum of, where do we have all our capabilities, these technologies, and how do we work with them? Well, the 5 main questions of data analytics fall within the continuum of what happens, what is happening, why is it happening, and what will happen, and what do I want to happen? And essentially, that's the classic 5 questions in the science of business intelligence or data analytics. And within these parts, we could very much understand where we are in terms of what happened in the past. So what happened in the past could have all our big data, let's say here in this example of accidents that happened around the city. So we had like 5,000 accidents, 10,000 accidents that happened over the last 10 years. We aggregate this data, we start understanding which accidents happen on the weekend, which ones happen on the weekdays, which ones happen in the morning and the afternoon, what is the environment surrounding these accidents. So you could build up a model, a predictive model or understanding model of what exactly happened in the past. So that's the past bit. And then with the IoT, with all the stuff, all these sensors that we have nowadays, we could understand exactly where the accidents now happened. So things like within certain intersections, down Taksim Square, there was an accident. Downstairs here, we've got another accident. So you understand exactly what's the state now. Why is it happening? And that's the analytical part. That's what I'm here now to talk about, which is how to analyze this data on the fly or go now and understand what, based on all this information I had in the past, based on the model I've created, how do I understand now why something happening in real time? I don't want to sit and start analyzing things, but I could have, based on the data already analyzed of 10 years, I could understand why is this happening now straight away. It's a weekend. It's busy in Taksim Square, and that's why an accident happened there. The weather was foggy in this time of the year, and therefore the accident happened. What will happen, and that's the predictive analysis part. What if I take this model and take my forecasts of weather in the future, take my congestion state in the future, take all these elements, thousands of elements I've got, and start building a model to predict what will happen within the next week with a certain, obviously, level of error. But what do I want to happen? And that's the important bit. How do I optimize my assets? So based on my model and my understanding of the dynamics of the city, where accidents occur, for example, where do I put my police cars? Where do I put my emergency vehicles or my police officers? And that's exactly what we want to do to save money, better allocate resources, and therefore save lives. So to talk about that, there are several parts of analytics that I want to sort of separate here. So in the first bit, let's say I'm an organization. Let's say I'm a transport agency. I've got lots of cars. I've got buses everywhere. With these transport data, I've collected transport data. I want to analyze it. What else do I want to do? What if I'm in a smart city where I can share data with all these other organizations? What if I can get my telco data? What if I could get demographics very easily? What if I could have access to utilities, to weather, to events, to land use, banking data, for example, and understand obviously on an aggregate level, I don't need to expose all data, but I could understand what are the other elements that operate within a city. Take all these elements together, put them together, and start building models and drawing correlations in order to do some exploratory analysis to understand exactly what are causing delays in your bus times, what is causing accidents of your buses, for example. But based on that, what if we have a big amount of data? So we get layers and layers and layers of all these big types of data, and I want to do very intelligent analysis, to apply machine learning and do play with lots of other algorithms in order to better understand what is causing that in a very deep manner. And that's when I want to use a mechanism, something strong that deals with this huge influx of information. And that's when I use big data repositories and big data mechanisms in order to ingest this big amount of data. Okay, I don't need to preach about that. You understand that. But I just wanted to separate these bits from each other. First thing I want to talk about is exploratory analysis. And within the ArcGIS continuum, we have a tool for that, which is called Insights. And what Insights does is that it kind of tries to take a smaller amount of data. I wouldn't say like it doesn't deal with big data, but deals with lots of types of varieties of data. Very easy to use. If you're a GIS user or a non-GIS user, you could use this interface and easily gain an instant understanding of your data. And an example here is about you've got lots of accidents, several accidents, happening within a city. You've got another layer of lots of schools, okay? So I want to understand the accidents that happen close to schools. What is the cause of them? How do I stop these accidents? So what do I do here is I open service areas, or I basically open buffers as well, to kind of gain within 50 meters or 100 meters all the accidents that happened within school locations. So I filter my accident data based on schools. What I do afterwards, I could easily just automatically draw a graph that shows me the day of week. So we have when the accident happens. And here, funny enough, you can see that on a Saturday and a Sunday, that's when accidents mostly happened. Most crashes of cars, of vehicles, happened on a Sunday and a Saturday. And thinking about it, well, why do they happen on the weekend? They don't happen on the weekdays. And that can help you gain information to understand that, well, when people don't see kids around on weekends, people tend to go faster. And therefore, chances are you would have more accidents on weekends. So that's one element. Another element there, for example, is seeing basically what are the speeds that were captured of the vehicles where the accidents happened. And that, again, shows you that most of vehicles weren't very speedy. They were at 35 miles per hour, more or less. And that gives you an indicator. How do I slow down vehicles? Is speed the problem? Clearly it's not. Is the weekdays and when kids are around, is that the problem? No, it's not. So that helps you gain an instant understanding very easily of your cause. Another thing here is, again, crime analysis. So I've got lots of data here, crime data for a couple of years in the city of Philadelphia. That's, again, Insights, my interface. And what do I do here is that I instantly drag and drop my data. I can classify crimes by type of crime, so whether it's a burglary, also theft, is it a murder, rape, and categorize that automatically by using colors and interactively, as you can see, I can see how they are categorized on the side. I can interactively click on a timeline when accidents happen and see these points interact on the map, so I can see them turn on and off based on the timeline that I'm clicking on. I can also generate heat maps, so I can generate instant heat maps and realize based on the time, space and time, where they do happen. That helps me very much gain instant understanding of data without having to take it to a ArcGIS desktop or desktop application. That's all web browser based, so that means that it could connect to your portal. If you've got ArcGIS portal, it could connect to other databases. You could simply drag and drop a CSV file that has data sets and drag it and drop it into Insights. And what you do here is that you could, here, for example, I have all my accidents, and I've got neighborhoods of the city of Philadelphia, and I literally drag and drop. I could drag and drop these accidents into the borders or the boundaries that I've got, and it automatically classifies and shows you, aggregates, finds the point and polygon, tests very fast, and it calculates how many accidents, how many crimes happened within these polygons. So as you can see, it's very easy to use. It's very simple. I don't need to be a GIS expert to go and do buffers, to go and do these calculations, have a model flow to understand and analyze my data. Other things I can do is, again, I could do things, statistical elements, such as understanding exactly what is the distribution of the data within these cities, these neighborhoods. I could also understand the differences, the differences between a year and the next year. I could do these calculations on the fly. I could also, apart from that, I could create a model out of that and save it and create other tabs to create more analysis on the same data sets I'm playing with. Okay, so the amount of things you can do here is just limitless, because the thing is you could easily take that data set, connect to other layers from CSVs, and have data sets from different types of data types, put them in one map, and visualize that on the same map and do your analysis based on that. Okay, jumping up notch, so moving from exploratory analysis, I'll move on to big data. So what do we do here in terms of big data? Well, we've got an element here that I've just mentioned, which is called Geo Analytics Server. What Geo Analytics does is that it parallelizes your processing. So in English, not Turkish, sorry, but in English, what it does, it just takes one buffer that you do on your machine, and rather than doing 1,000 buffers of 1,000 points in one go, it distributes that on 3 different machines. So it cuts that into 300 something on one machine, another 300, and another 300 something, and then does these aggregations, and then everything comes back to the same machine. Parallel computing in its easiest form. So ArcGIS understands that and understands the operations that are carried out by GIS people, and tends to understand how to distribute these operations over different machines. Okay? So that's exactly what Geo Analytics does. So it does what the normal buffers you would do, the drive times you would do, but on a bigger amount of data. So today, with a big amount of telco data that you get all over a city or the world, telco operators have a big amount of data. And as you can see, the flows are immense, are big. And this is data collected, or data that is done by our partner, Teralytics. And what they do is, essentially, they start calculating origins and destinations, movements of people across a city, and trying to build models based on that. That's all based on ArcGIS. So what we do in this space is several things. Let me tell you one story. So one thing we could do here, is basically aggregate this big amount of data. That's the city of New York. But I could aggregate this data into higher level and break it based on time and space. So that could help me with a time slider here, try to see where patterns emerge. Where are people concentrated most of the time? How does the pattern increase, like somewhere around Central Park there? Why are people there at that specific time of the day? And I could visualize that in very different ways. I can build 3D cubes like up there in the screen. There are lots of ways I can visualize this data once it's aggregated. Once it's aggregated, it's not big anymore. It's small data. That's a web browser, actually, using the Python API in order to visualize this amount of data. And you can see all the sort of land surveying techniques, the 3D and tin models are built on top of my area in order to show what's the distribution, the spatial distribution of that data. Another work that we've done here was basically with Smart Dubai. And with Smart Dubai, again, we took a telco operator's data, a huge amount of data, calls. Whenever anyone does a call, the location of that user is recorded. What we do here is we build a model of the roads. So we snap all these calls to the nearest roads. So the roads, you understand exactly where things occur on the road, when congestion happens, where people are going slower, when people are going faster. What you do here is try to build a model based on that and try to understand, in an attempt to implement smart cities, I try to understand what's the flow of people and try to make that flow better. So essentially, just like Richard is going to mention in a bit, Richard's going to talk about examples of smart cities, but that's essentially one of these applications. That's essentially showing how we could use all this data from these different organizations in order to analyze the data for a different sector. Again, just like what Richard was saying earlier on, how do all organizations, government organizations, come together, share data, share a certain amount of data together in order to do things like that? So in the end, I could build models based on the neighborhood, go within communities, and see the origins and destinations of these communities, understand the migration that happens from one community to the next. Other examples here are, again, the crime trends. So that's a web application that basically shows me basically crimes, how safe my neighborhood is. So if I'm thinking to move to that specific part of the city, I could literally start manipulating the map, opening a circle and seeing what's the distribution of crime around my neighborhood. It's very interesting. That's what we were talking about earlier on. That's community engagement. I'm engaging with the citizens, so the citizens can understand to make decisions based on the data that our government is sharing with them. Other things are here, like with Abu Dhabi government, that's an attempt again to predict traffic on certain main roads, what they call arterial roads. And that's, again, a very interesting concept of taking that data, that telco data and smartphone data, and doing other things with it, transport-related problems. So a third bit, which is the last bit I'm going to talk about, is intelligent analysis. And essentially, what we do here in Esri has a big stack of functionalities and capabilities that we've got. Among these, you could use, as we mentioned before, as Dean has mentioned before, we have R Bridge in order to interact with your R algorithms. We've got Python, and that you could use within Model Builder, within ArcGIS Desktop, for example. And you've got lots of spatial analysis techniques that you could use, thousands and thousands. But you also have some predictive techniques. You don't have a big stack of predictive techniques, but we do lots of imagery. You could do lots of feature understanding and feature correlations. And pretty much I can build whatever I don't have here, I can build on my own. Lots of developers do these solutions on their own. Examples of these is an example here taking, again, smartphone data, people moving around the city, and trying to build an algorithm, a machine learning and artificial intelligence algorithm on top of that data in order to translate people movements from just movements to whether they're walking, cycling, riding a bus, riding a train, and understanding where the stops happen, where do these stop, and imagine having another layer behind that, again, all the land use of where people stop, and extract and saying, well, people tend to stop a lot at a certain shop, or tend to stop a lot at a bus stop, at that specific bus stop, at that certain time of day. You could build these big patterns based on just simply X and Y coordinates. Well, X and Y and time as well. So that's work again done, work done in London. And other research work as well has been done in the same sort of scenario to take all the weather components. So again, seeing does weather have an actual impact on transport, and if it does, what levels of weather do impact transport? And here we could say, like, if rain is only 1 or 2 millimeters per hour, if that's the level of precipitation that I've got, then it's not going to affect traffic in the city of Istanbul, for example. But from this level and above, then yes, we have a problem. And that's when you know where to allocate your resources. And other things are like predictive analytics based on, again, you want to predict where accidents happen. And that's exactly the scenario where we're talking about. So you can bring in your incidents, the locations of where they happened, the time, and the weather. And then you realize that based on these elements, all these data sets, I could create a predictive model that helps me basically create maps and communicate with decision makers based on certain visualizations and maps that I give to decision makers. Decision makers, lots of the times, don't understand GIS, but what they understand is pictures. They understand numbers. And that's what GIS does. And you can build up on that. This is what we contribute here. You can build up lots of elements in the space and time continuum. So you could say, like, if an accident happened within a curve of the road, so how far away were you from the curve of the road? You could you could put things, another element, which is, was it a single carriageway? Was it a double carriageway? Other things like the number of lanes where the accident happens. Was it 10 lanes? Was it a wide road or a thinner road? All these elements, whether there were events, the weather conditions, you can expand based on all the data you've got. And that's why I was here focusing on the collaboration of government entities together. What if I can get data from telcos, what I can get data from utilities and other organizations? That's when I can build these sort of models. And in the banking industry, I could also do other things, like based on the telco data that I've got, I could launch certain campaigns. So what if as a bank, if I have all the transactions data, I could manage them and aggregate them based on certain areas, certain locations. And therefore, I could, as here in this example, as Starbucks, for example, they're informing their marketing strategy based on that information they got from a telco operator. Sorry, from the bank, from that transactions done by the bank. And therefore, they could say, well, I will launch my campaign in this area because I'm targeting these types of people. I'm going to sell these people a cappuccino because these types of people with that specific type of spending, the people that spend money on things like Massimo Dutti clothes, for example, they're the type of people that also would drink a cappuccino, for example. So these are the correlations that you could draw, and hence you could inform your campaign. And not just that, you can calculate your return of investment based on the IET. So if you have all this information coming live, all these transactions coming live from your shops, from your Starbucks shops, you can then understand where are these coupons, where are these offers being used a lot. And you can build real-time analytics based on that. So to summarize here, what I wanted to say is basically that we used all these technologies, this big stack of technologies, in order to put location in them and start building all these cool applications based on them. I have lots of, starting with all the sensors and the IoT elements, I build all these live dashboards, go into the big data and the cloud computing capabilities. I could summarize data, aggregate it, extract patterns. There's always a pattern. I could also use advanced analytics in order to understand, do clever things, do predictions where things are going to occur. I could also show that in the end to a decision maker, tell him basically, this is the trend, this is how it looks like, this is how you've got all the information now, take the right decision. And then you could also communicate afterwards with people in the streets and people on their phones. You could also collect information from people on the phones using your desktop and mobile applications and have a desktop GIS in order to analyze that big stack of geospatial information. So on this note, I'll pass it back to Richard. Thank you.
Thank you, Adel. That stuff blows my mind. That's some amazing things there. It's really great. So yes, as we said, 5 key capabilities here for leveraging GIS for smart cities. So we're happy and pleased to encourage you to start exploring how these ideas can start supporting the cities you have here in Turkey. Now I'm going to take just 5 more minutes. I know we're running a bit late. To talk to you about an example of where Esri has actually implemented some of these technologies in a real smart city, and that is the city of Dubai in the UAE, where Adel and myself both live. The Smart Dubai initiative was launched by Sheikh Mohammed, the ruler of the city, back in 2014. And the Smart Dubai plan is all about creating happiness by embracing innovation in technologies. They have a framework which is built around 4 key pillars and 6 key smart dimensions, enabling efficient, seamless, safe, and impactful experiences across the city. And really what it boils down to, their key vision is making Dubai the happiest city on the planet. Now that sounds like a very lofty goal, but it's something they're very serious about. And this idea, this concept of happiness is something that's gaining huge traction around the world. And Dubai are really the leaders in this space, doing some great things. Over the last 3 years, they've launched a range of different solutions, initiatives, and strategies. They have a happiness agenda, which is measuring the happiness of people and citizens around the city. They've created the Dubai Pulse application, which we'll talk about in a minute. They're leveraging blockchain as a strategy to reduce the paper transactions across government down to 0 by the year 2021. And then the year 2021 vision that they have as well is feeding into the work that they're doing. They've launched a range of products and solutions that leverage mobile technologies, enabling us to pay for our electricity bills online, pay for our traffic fines through mobile apps, those kind of things. Now, all of this work, whilst the focus is on creating happiness for the residents and the tourists and people that come to the city, it's also got a huge financial benefit in that the government has saved $1.2 billion through the implementation of these smart services in the years between 2003 and 2015. So for every dollar that they spend, they save $5.6 across government. So a huge amount of financial benefit, as well as providing this happiness agenda for the citizens. Now, as I mentioned back at the beginning, technology and data are crucial to cities enabling these smart things to happen. And from the very start, Dubai identified that data was the key aspect that brought all of these things together. They've placed data at the heart of their smart city strategy. Infrastructure and strategic considerations are also very important, but really data is right there as the key thing they're working on. And we are very pleased to announce and say that Esri has been chosen by the City of Dubai as their GIS platform partner. So all government agencies and all government authorities across the city are leveraging the Arcgis platform as their geospatial standard for the city. So that's really great news. Now, we've done some work with Smart Dubai over the last couple of years, implementing some applications on their Dubai Pulse platform, which is really, as we talked about earlier, it's about bringing data together from different government organizations, bringing that into context, and looking at the patterns, looking at the trends, and looking at how that we can really drive better information and better decision-making from that information. This is the Dubai Pulse application that we created for Smart Dubai. This is a citizen engagement application, in fact. It lets citizens and residents and tourists understand information and things about projects that are happening, like the new Dubai Opera House that was recently opened in the downtown area. We look at things about events that are happening across the city, and we can look at interesting places and data and information and KPIs and metrics that are coming from government. So again, this is a facilitation of a communication mechanism between citizen and government. And with integration through Facebook and other social media platforms, people that live in the city can actually comment and provide feedback to the government. So this is one of the ways that Dubai is capturing information about the happiness agenda. They're understanding the sentiment of people, you know, how are people reacting to the kind of work that's going on across the city? How are they reacting to the events like the Expo 2020 that's coming in a couple of years? So really this is becoming an engagement tool for citizen and government. We also have an application that brought data together from different organizations and enables people moving to the city to plan and decide where they want to live more effectively. So we have data in here from the Dubai Economic Department, from the Roads and Transport Authority, from the utilities, from the schools and academic organizations. And by selecting and modifying these different sliders through this application, it actually highlights areas of the city that you might be interested to live in because you want to live a certain distance from a metro station, you want to access a certain type of education, for instance. So this is helping, you know, government, helping citizens make decisions about where to live and where to work across Dubai. They've also got plans around being more sustainable, and I mentioned this earlier as well, and driving better energy generation from sustainable sources such as solar. Of course, Dubai being in the middle of the desert, we have a lot of sunshine, so why not make better use of that and actually implement solar panels on buildings to start both creating energy for your own use as a resident and as a business owner, but also feeding that electricity back into the grid to save money on your electricity bill. So this application is live now on the Dubai Electricity and Water Authority website. You can go on here, find your house or find your villa, and understand the solar potential that could be gained from implementing solar panels on your building. And then you can go through into a workflow and actually apply for a permit to implement solar panels and work with the government to actually meet their objectives around creating renewable energy. The final example is the Dubai Design District. This is a brand new real estate area near downtown Dubai that's for cultural and design-oriented real estate organizations. This is an IoT-enabled command and control center application that brings data from multiple systems together into a 3D GIS-enabled application. So the users of this application are the district owners, the people that run the district and the people that actually lease space in these offices. So they can access information about the work order system, for instance, see how many open work orders there are, see how quickly they're being closed, look at different statistics and measurements of the KPIs that have been set. It also pulls in information about energy consumption, so how much electricity, how much water is being used across the district. And this goes down not just at the building level, but to the floor level, and indeed down to the individual units, the individual office spaces in the buildings have IoT-enabled sensors within them. And that data is being streamed in real time, as Adel mentioned, into this application, enabling the people that run the district to do so in a more optimized fashion. So that's obviously creating savings and efficiency gains, which is making this a very attractive place to come and set up your business and go from there. So we've got lots of work going on with Smart Dubai. You know, we've really scratched the surface of the things that we can do with the city, and we're looking forward to moving forward and implementing more smart technologies with them over the coming years. And so with that, I would like to say thank you for joining us this afternoon, and enjoy the rest of the conference. Thank you.